Alright guys, we are coming back with contrast and receptor exposure. So kind of the other parts of that imaging chart that we need to figure out what controls each thing. So just a little bit, the difference between the two. So contrast in your image is the difference in brightness levels between adjacent areas. Digital contrast is primarily controlled by the lookup table. We're going to split it into digital contrast and subject contrast. We'll go into that in a few minutes. Receptor exposure, and when you hear the word receptor, I want you to think your image receptor. How much of that radiation is passing through the patient and hitting your image receptor? It could be a collection of primary and secondary radiation. And receptor exposure is primarily controlled by your mass. So I'm going to start with contrast, and then we'll move on to receptor exposure. And I know you're going to say, Megan, contrast was taken out of the chart for ART. Well, contrast resolution is still on the content spec list. I realize it's not in the chart anymore, but if you look further down, it's still listed. And so we have to know some of these things. We have to know what factors have no effect whatsoever. Remember mass? Mass only plays in the receptor exposure sandbox. It does not have anything to do with contrast. SID has nothing to do with it. Focal spot size, nothing to do with contrast. Motion, angle of any kind, these do not come into play. So if you know the players that do come in and the players that don't, these questions are easier because you could say focal spot size has nothing to do with contrast. That can't be my answer. Right? Just a general of scale of contrast. Remember, we have short scale and long scale. And you guys know how I describe my little short scale of contrast as my short little penguin. Likes to get high. He's a naughty penguin, all right? But mainly black and white. We're going to use a low KVP, but it's considered high contrast. So short scale of contrast is considered high contrast. And so I use my little penguin. Long scale of contrast, there's a lot of gray in between that black and white. These are going to be your higher KVP settings. Long scale is considered low contrast, so I use a big gray elephant to help with that, right? Okay, so if there's a lot of shades in between black and white, it's a longer scale, or low, long and low. If there's mainly black and white, maybe one shade of gray, it's considered a short scale. Digital image contrast is controlled by quite a few things that come into effect, but you'll see none of these are KVP. Okay. Your lookup table is really your primary controller. It's that mathematical process, and it's going to sort of add the desired contrast to the image. It uses an algorithm. It's an automated process. It's not something that you as a technologist adjust or change. Bit depth. This is sort of my allowance of gray shades. It's the number of gray shades that I can use. Greater bit depth, more gray tones, right? We know 8 bits is 256 shades of gray, right? So the more bits I have, the more gray levels, the more information. Quantization kind of goes, it's on the same team as bit depth. Bit depth says you can have this many. Quantization is going to display or select the specific brightness level. DQE, or detective quantum efficiency, is used to measure the quality of the digital image. It evaluates the effects of noise and contrast on the image, or we might know as SNR, so signal to noise ratio. How much signal, which is your useful image, compared to how much noise. And ideally, right, you always want high signal, low noise. DQE lives on the contrast side, right? Window width is your post-processing controller of contrast. This is something as technologists we can change. Once your image is up, right, post-processing. When it's done, if you want to make adjustments, you can use your window width. Right. There's some terminology here similar to that of that long scale, short scale. They might call it wide window width or narrow window width. A wide window width is a long scale. A lot of gray. Narrow window width is your short scale of contrast. Okay, so if we can keep those in our brain. But remember, Windowing is a post-processing option. The lookup table, the bit depth, the quantization, I as a technologist cannot control. So those are not post-processing.